Yeah, so is my screen visible?
Yes, ma'am.
Okay, wait a minute. Hmm. Okay, so can someone summarize what we have done during the week? Have you gone through the week's lectures?
Yes, ma'am.
Okay, so what did you study?
In week 3 lecture, tell about the displacement analysis
Mm-hmm.
of the forward kinematics and inverse kinematics problems.
Okay, so did you try the assignment?
Yes, ma'am. I try the assignment.
Okay, so when was the due date of the week 3 assignment? Is it already
Uh,
gone?
yes, ma'am. It was already gone.
Okay, so by the way, when was it?
Um, 12.
Okay, so were you able to solve like maximum questions?
Ma'am, basically, I watched the lectures, week lectures,
Uh-huh.
and some of the like previous live sessions.
Okay, so um, uh, okay. So who's the another student, Chandrasekhar? Can you summarize what you did in forward and inverse kinematics problems? Like basically define them. Because see, this is supposed to be an interactive session. So if you're watching the lecture again, like the video lectures, it
Yeah,
won't make sense.
yes, ma'am. In forward kinematic analysis,
Mm-hmm.
the inputs are given and actuators position we have to find. And in an inverse case, we have to be given that actuator positions, and then we have to find the inputs, what are the angles and other things. Uh, these are the basic differences.
No, basically, actuator is itself the input link mostly. So the input uh, motion is given, and we have to find out the output motion. It can be a link or whatever. Okay.
This one is the
Yeah. And
forward
in
and
inverse, we have been given the output motion, and we have to find the input
input.
angles or whatever kind of motion it is there. Okay. So basically, displacement analysis of 4R and 3R 1P chains you would have done, right, during the week lectures. And
Mhm.
after that, you must have studied something about steering mechanisms, okay, the perfect steering condition, etc., right? So those are some important things. Now I think we'll directly move to the numerical problems, okay? So, okay, is this clearly visible to you? Let me zoom it a bit. Uh, okay, are you able to read the question? Okay, so here we have
Yes,
been
ma'am, it's visible.
okay, so we have been given that we have to calculate the angle of link CD with the x-axis of the 4 bar linkage shown below. AB is equal to 300 mm, BC is 450 mm, CD is 600 mm, and AD is 700 mm. So basically, you can clearly see this is a 4R mechanism, and this angle, okay, let me change the pen. This angle is theta 4, okay, or theta output, whatever you call it, whatever you like. So AB is given as 300 mm, BC is given as 450 mm, CD is given as 600 mm and this AD is given as 700 mm. So how do we proceed with this question? Can you tell me? Like what is the approach you follow in this sort of questions?
There is a relation between the angles and the given length, I think.
Yeah, so
I forgot actually, ma'am, the relation, but
no, see, you cannot forget the relation because you will be requiring that. And even you don't need to remember it. You can derive the whole thing, right? So
mm,
you can set a coordinate axis. This is your origin. You can write the basically the coordinates
yes,
of this
we
point
can
from
derive
onwards.
that
Yeah,
300 cos 70 and plus like positions
yeah.
of B, C, and
So I want you to solve it. Okay, I want both of you to solve it. So I'll give you 2-3 minutes. Then you can solve and tell me what you are getting. Then we'll move to solution part. Okay.
okay, ma'am.
I'll show you the standard procedure for one problem. Then we can directly use the formula. Okay. But for one
Okay,
question,
ma'am.
we will go through the standard procedure, like how do we solve it. So did you do similar problems in the assignment as well, like in the new assignment?
No, ma'am, I couldn't.
Okay.
Actually, I forgot to submit that assignment. I tried one or two problem I tried, and I was waiting for that this session.
Yeah, so basically, what happened this week is that usually the session is on Sunday, 3 to 5 p.m. That is the regular session. So, week 1 and week 2 session were conducted way before your assignment
Yes,
deadline.
yes, ma'am. We did that one.
Yeah,
For big one and big two, we did that.
yeah. So, in week 3, I had my exam. So, I wanted to postpone it to Wednesday, but the PMRF team said that they do not have classes on Wednesday and Thursday. So, that's why I had to shift it to Friday. But yesterday there was some issue with my PC. Basically, I don't know why the mic or the sound is low. So yesterday recording was not happening, so I couldn't upload it later. So that's why I shifted the session to today.
Okay.
So anyone got the answer?
Tan theta for A and B. Tan.
You guys can mute yourself. When you reach to the answer, you can unmute. Okay, so if you are doing it, you can continue your solution. But let's discuss how we do it. So basically, we need to find this theta 4 here, right? So this theta 4
Yes, ma'am.
is the basically the output and we need to find it. So what is the basic procedure we can follow here is that for us, what are the known parameters? The link lengths are the known parameters. The theta input is the known parameter and the theta 4 is the unknown parameter. So we would want to express theta 4 in terms of the known parameters, right?
Given.
Yeah. So the standard procedure is basically that you consider this link 2 and it has these 2 points, right? B and C. So what are the coordinates of point B? We can see that coordinates of point B are, it is this link is 300, so the x coordinate will be what? 300 cos 70 degree.
300 cos 70.
Yeah, 300 cos 70 degree. After that, the y component of this will be 300 sine 70 degree, right?
Yes,
300
ma'am.
sine 70 degree. So this is straightforward, right?
Yes,
Now,
ma'am.
for the point C, what will be the x coordinate?
300 cos 70 plus 450 cos theta 3. If we assume theta 3 at the point B,
Okay, you can do it that way also, but I have done it in reverse manner. What I have done is I have considered this whole length and subtracted this portion from here, right? It will be the same.
yes,
So what I have
yes,
done
ma'am.
is it will be 700. Now look close. I could have written 700, but then I would have to consider cos of 180 minus theta 4, which would be cos of minus theta 4. So that minus will
Yes,
come out. So I have written it as 700 plus 600 cos theta 4. Understood? This
yes,
will
yes,
be the
ma'am.
x coordinate. And for the y coordinate, it's simple. The sine theta 4, 180 minus theta 4 is equal to sine theta 4, because in second quadrant, the sign is always positive. So you can simply write it as the y coordinate is 600 sine theta 4. Okay, otherwise it was 600 sine 180 minus theta 4, but I can simply write it as 600 sine theta 4. Clear till here?
Yes, ma'am.
Okay. Now, what we do next is that you know how to find the distance between any 2 points. So, give me the equation for that. Tell me what it is. It will be. It will be
Y2 minus y1 upon x2 minus x1.
Is equals to y2 minus y1 upon x2 minus x1.
the distance between any 2 points. We can simply write as x1 minus x2 whole square plus y1 minus y2 whole square ka root over, right? That is the
Yeah,
distance.
Yes,
So
ma'am.
yes, ma'am.
450 square will be nothing but it will be 700 plus 600 cos theta 4 minus 300 cos 70 squared, and then it will be plus 600 sine theta 4 minus 300 sine 70 degree whole square, right? Okay, some people are still
Yeah.
joining. Yeah. Now, since we have arrived at this equation, okay, so can you simplify this and give it the equation you are getting in terms of a sine theta 4 plus b cos theta 4 is equal to c. Simplify this equation. Is it visible to you? Let me take it. Wait a minute. Cut, and we can paste it here. Okay, what is happening? Hmm. Okay, let me just. Is it visible?
Yes, ma'am.
Okay, if the we still transfer it a little bit up so that it's clearly visible. Uh, I hope now it's visible, right? So it is 450 square is equal to 700 plus 600 cos theta 4 minus 300 cos 70 degree whole squared plus 600 sine theta 4 minus 300 sine 70 degree. Okay, now please simplify this equation and give it in terms of a cos theta 4 and b sine theta 4 equal to c, and tell me what you're getting. Let it be here, it's fine here. Done, anyone? Actually, let me write it here also. Anyone got the equation? So it is 450 square is equal to 700 plus 600 cos theta 4 minus 300 cos 70 squared plus 600 sine theta 4 minus 300 sine 70 degree whole square. So the only variables here is theta 4. So basically we will simplify this equation in the form of a cos theta 4 plus b sine theta 4 is equal to c, some constant. So please simplify this equation in that form and tell me what you're getting. Has anyone done it?
No, ma'am. Actually, we don't have calculator right now.
Sorry?
I don't have calculator with us right now.
Then you should be present, no? Like you should have calculator. You cannot come into the class
Yes,
without
yes,
it.
ma'am. I forget to bring that.
You can use your phone, right? Do you have calculator in
O-
phone? Or you must be at
Okay,
your
ma'am.
home, right? So this is not an excuse that we don't have calculator. Then what is the fun of coming to the live class if you're not solving here? Even if you have missed assignment
Gi-
3, these things will be asked in exam also, right? There
Yes,
you have
ma'am.
to do it on your own. So anyone
Give me
else?
2 3 minutes. I'm come with that.
Sorry.
I'm coming with calculator, ma'am. Give me 2 minutes only.
What about others? Is anyone solving it? This is simple quadratic equation. You don't have to do anything. You just have to put in the values, put the value of cos 70, sin 70, and then simplify this equation and tell me what you are getting. Okay, so I'll not solve this whole equation. I have done it already. So when you simplify it, it comes in the form 338 point sorry. So when you solve this equation, it comes in the form 338,289.6 sine theta 4 minus 716,872.8 cos theta 4 is equal to 593851.711. Okay, so this is the equation you're getting. Now the standard procedure for solving this kind of equation, okay, which is in the form of a sine theta 4 plus b cos theta 4, okay, is that we substitute sine theta 4 and cos theta 4. So how do we do it? So do you know about the half angle formula? We know that cos 2a is equal to what? 1 minus tan square a upon 1 plus
Tan square A.
tan square a, right? What is sine 2a equal to?
Ma'am, 2 tan A upon 1 plus tan square A.
Yeah, correct, right? Now here it is sine theta 4. So let us consider a is equal to what? Theta 4 by 2. Okay. So wait a minute. Let me insert another slide. Yeah. So what is 2a here? 2a is equal to theta 4. Or let me simplify it in a different manner. Okay. We can consider this equation to be as a sine alpha plus b cos alpha is equal to c, right? And so let us consider 2 alpha. So this is basically 2a is equal to what? Alpha, right? 2a is equal to alpha. So basically a is equal to alpha by 2. So here instead of 1 minus tan square a, you will write 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. And here sine 2a, so you will write sine alpha is equal to 2 tan alpha by 2 and 1 plus tan square alpha by 2, right? So now what this equation will turn out to be, it will be uh, here a. So instead of sine alpha, it will be 1 plus tan square alpha by 2 upon, okay, sorry, 1 minus it will be 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2 plus b times, what is it here? So cos alpha, instead of cos alpha, okay, I think I have, okay, so this is b here and this is a, okay, that's not a problem, b will be here A will be here. So A will be what? A will be 2 tan alpha by 2 upon 1 plus tan square alpha by 2. So let's call tan alpha by 2 as m, okay, because this like this equation is looking a bit messy. So we can write it as a into 2m upon 1 plus m square and plus b into 1 minus m square upon 1 plus m square. So on the left hand side we have simply c, right? So we didn't make any substitution for c, okay, in this equation. We didn't make any substitution for c. So it is simply like that. Any doubt till here, or is it clear to you? Any doubt till here? Now, yeah, somebody has to say something. Okay. So now we can solve this equation. It will be 2ma plus b into 1 minus m square is equal to c into 1 plus m square, right? Is it okay? Is it okay till here?
Yes, ma'am.
Yeah. Now you can still simplify this. Okay, so you can write it as 2am plus b minus bm square is equal to c plus cm square, right? Now it is a quadratic equation in m, because obviously m is tan alpha by 2 and alpha is not known here, okay? So what you can write it as is c plus, taking this coefficients here, so c plus b m square, right, and minus 2am, right, then plus c minus b is equal to 0. Now tell me the roots of this quadratic equation. You can compare it with this, right? This is your a, this is your b, and this is your c, okay? This I have already given you. Now you can compare these coefficients and you can solve this quadratic equation. So tell me what the roots you are getting here. Quickly. Please keep a pen and paper with you and you note down these equations at least, so that whenever I ask to solve anything or calculate anything, that you should be able to give at least. So compare it with this equation, okay? Here this is your a sine theta 4 minus b cos theta 4 and c, okay? So you have these coefficients a, b and c. So give me the value of this quadratic equation. You can solve it, right? You know the roots of the quadratic equation is equal to minus this coefficient of m plus minus under root of b square. This is 2 4a square.
Mom, it's a plus minus root over a square plus b square minus c square by c plus b.
Yeah, correct. So can you put in the values and tell me what the values you are getting for m, because I have given you the value, no? You know from this equation you what a is, b is and c is, okay? So tell me.
Yes, mom. Mom, can you please once again tell the values of
Okay,
ABC?
let me write it.
I just joined late.
Okay. Yeah, so a is equal to 338,289.6, b is equal to minus 716,872.8, and c is equal to 593,851.7117. So these are the values of a, b and c. So you can simply solve it in calculator also for now. Okay, did anyone get the values of the quadratic equation, the roots of the quadratic equation? Okay, so what happens is,
Ma'am, 1 is something 1.5.
yeah, 1 m1 is equal to 1.51818, okay, and so on. What is m2? Another root. Okay, so when you do this one, it is coming out to be minus 7.01788. Okay, so these are your roots. Okay, you get it from here. Now what we had considered m to be tan of alpha by 2, okay, or basically theta 4 by 2, whatever you write. Okay, so let me write it as theta 4 by 2 only. So this is your first solution, right? Or tan of theta 1 by theta 4 by 2 is equal to minus 7.017. Now from the first solution, theta 4 by 2 is equal to tan inverse of 1.51818. Okay, or second solution is theta 4 by 2 is equal to tan inverse of what we get minus 7.017. So it's minus 7.017. So quickly tell me, what is this value coming out to be? We can call it theta 41 and theta 2. Yeah, so what is theta 41 coming out to be? When you substitute this value, let me, tan inverse of 1.51818.
Ma'am, theta
56.57.
4 was
Yeah,
133.25.
exactly. So this will come out to be 56. Then will when we multiply with 2, it is coming out to be theta 4 is equal to 113.255, right? And for second case, what is the
Minus 163.77.
yeah? So theta 4 2 is coming out to be minus 163.78. Now see, what is the catch here is, whenever we write tan alpha is equal to tan beta, we know that alpha is equal to n pi plus beta, right? So here also we have equated tan of theta 4 4 1 by 2 is equal to tan of something. So when we are equating this, it's not necessary that this is the answer. Okay, so what we do here, we add 180 to it. Okay, so when you add 180 to first solution, or basically what we can do is, see, this was something like this, right? So this was your theta 4 1. So uh, this is the angle you are getting, but if you are measuring it in clockwise direction, then it will be 113. But if you are measuring it in anti-clockwise direction, it will be what, 360 minus 113.255. Okay, so it will come out to be 246.745. So this angle is equivalent to this angle, right? And what about 163? What will it be equal to? So 360 minus 163.78. this will be equal to 196.22. Okay, so here in the options, if you see, okay, wait, say it. So yeah, 196 and 246 is the correct answer. Okay, so this will be your angles. Okay, any doubt till here? So yeah, this you're measuring in clockwise, so it's positive. When you measure it in anti-clockwise direction, you will keep a minus sign with it. Okay, just to denote the direction in which you have measured. When we are solving mostly
When
the,
we are solving,
can you please mute yourself? It's coming echo. If you have to ask that time, you can unmute. Okay, otherwise you can mute. So basically, when we do such questions in the computer or any software, MATLAB, etc., we basically use the arctan function. Okay, so there we don't have the this issue of sign or anything. So the computer automatically solves it with that function. But here we have to take care of this. Okay, when you're doing it manually. Okay, any doubt in this question? Okay, so this is basically the standard procedure. Yeah, Nikhil.
ma'am, can you explain the one time the equation also that how you can do the 700 plus 600 cos theta 4?
Here, this equation.
Yes, ma'am.
Okay, see, so this is one point, this is another point, right? So you know that distance between any two points is what? Their x coordinates. Say this is point C, so and this is point B. So xc minus xb whole square plus yb minus yc whole square is equal to the distance between them, that is bc square, right? So bc is 450. Now what is xc? When you write the coordinate of xc, it is basically this portion. Now this whole length is 700, so from 700 you will have to subtract this, right? So that is what I have written as 700 minus 600 cos theta 4. Okay, then in other way you can do it like that also. You can draw a perpendicular here, as some student was saying also, that you can write it as this whole 700. Well, I guess you will, yeah. So what you can do is you can write this as 300 cos 70 degree plus 450 cos of this angle. Okay, you will have to figure out this angle and write it that way. So that is one way of doing it, but I have done it in another way, so I'll just stick to that. Okay, so what I did is, for calculating xc, you know that this whole thing is xc. So it will, sorry, this whole thing is 700 and this portion will be xc. Okay, so from 700 you will have to subtract this portion. Now what is this portion? It will be 600 cos of 180 minus 600 cos of 180 minus theta 4. Okay, you will have to subtract this, but then you know that cos of 180 minus theta 4 is minus cos of theta 4, so that minus will come outside, it will become plus cos of theta 4. So that is how you write xc. That is what I have written here, 700 plus cos of theta 4. And the y component of basically this b will be equal to 300 sine 70 degree, and for c it will be simply 600 sine theta 4. Okay, or sine 180 minus theta 4, but we know that 180 minus theta 4, sine 180 minus theta 4 is simply sine theta 4, right? So you can write that as 600 sine theta 4. Understood? So that is
Yes,
how I have
ma'am.
written this, and then I have subtracted and put in this equation. Okay?
Ma'am, can you please tell why did we subtract the angle from 360?
Okay. So see, uh, what is the general solution of tan alpha equal to tan beta? We know that whenever we say tan alpha is equal to tan beta, we do not say alpha is equal to beta. We say alpha can be n pi plus beta. Now here I was getting 113.255 degree, but if it was in the options I would have selected it. My whole purpose was this, because you can measure it both ways. Okay, you can measure it this way also, then you will write plus 113, or you can measure it this way, right? Then you have to write minus sign along with uh, the angle. So since in the options it was mentioned as 246, okay, sometimes it can be 113 also. In that case you will just tick that option. But if it is a little bit tricky, they can put it in this form. So what you will do, you will subtract this from 360, right? But since you have measured it in anti-clockwise direction, you will put a minus sign. Okay,
So
that is
ma'am,
the,
basically both are correct.
yeah, both are correct. Like you can put this also, but this is not in the options, right?
Okay, ma'am. Thank you.
Yeah. So, Nikhil, is your doubt clear?
Yes, ma'am.
Yeah. So this is the whole idea of solving these questions. Now, other another question similar to that. I will not follow the same procedure. Basically, as some student was already pointing that there are some formulas. If you want, you can memorize them. Okay, for the course you need to memorize them so that you don't have to solve the whole procedure. But doing this way is better. Okay, even you can solve these questions geometrically. There is not always one solution ki yeah, this is the only standard procedure of doing it and you will get the answer. You can solve the same questions by geometry also, and you can solve them by just remembering the formula of theta 41, the theta output. Okay, that sir must have taught during the lecture. So in the second question we will see it in that way. So yeah, is my screen visible? Is this
Yes, ma'am.
visible to you? Yeah, so I'll read it out so you can be more clear. So please have a pen and copy with yourself and try to solve it and try to write down the questions as well. Otherwise, there is no sense of coming to the live session, right? So the question is, calculate the distance S, okay, of the slider from the ground hinge when the crank angle theta is equal to 2 phi for the given assembly mode, where phi is the crank angle when the slider is closest to the ground hinge. OA is given as 20 mm and S max is given as 110 mm. So can anyone tell me what this question is asking? Whatever you understand by this question. Anyone?
They're asking the distance of S when the crank angle is at this 2 theta, sorry, 2 phi angle.
Okay, let me break this down for you. So basically, okay, let me. We have been given a configuration similar to that. This is OA, right? This is the, okay, this is a little bit below it. So this is the offset distance. It has been given, right? Yeah, offset has been given as 65. Okay, let me write it as E, and this distance is S. So this is typically a slider crank mechanism, and this is given as theta. Now what they have asked is that Calculate the distance s of the slider from the ground hinge when the crank angle theta is equal to 2 phi. So basically this theta here, they are telling that when it becomes 2 phi, okay, you have to figure out the distance of the slider. Now, what is the catch in this question is that, yeah, phi is the angle when slider is the closest, okay. So basically it is telling that when slider is the closest to the ground link, okay, it reaches its maximum. So here this angle will be phi, right? This angle will be equal to phi. And S max is equal to 110. So S max means when the slider mechanism is the farthest, okay. So you have been given 2 points. You have been given the crank angle when the slider is the closest, and you have been given this distance S when the slider is the farthest. So let us consider case 1 when the slider is the farthest, okay. So in that configuration, what will happen? This hinge will remain at its position. This OA will stretch completely, and similarly this AS, okay. So you know that this is the maximum limit the slider can go, right? This is 65 and this is the S max. Because you have completely extended OA, it is these are rigid links, it cannot go beyond this, okay. So OA was given in the question, right? So OA is given as 20 and this S max is given, right? Now how do we figure out this? This is equal to 110, this is equal to 65, this is equal to 20, and this is equal to, you can call it AB. So quickly calculate this distance, okay. You have to just apply the Pythagoras theorem. Hypotenuse square is equal to base square plus perpendicular square. So you can get this AB distance. Quickly do it and tell me what you are getting the value of AB. It will be 20 plus AB square is equal to 110 square plus 65 square. So what is the distance AB? Is the length AB equal to?
Ma'am, 107.76932.
Yeah, 107.769. Okay, so this is the length AB. Now we have got the length AB also. Now moving to the next part of the question, what it was saying is, calculate the distance S, okay, when the crank angle theta is equal to 2 phi, where phi is the crank angle when the okay. Now what we consider, we have been given the crank angle equal to phi when slider is the closest. So we will consider when slider is the closest. We considered first case when slider was at maximum distance. Now we will consider when slider is at closest distance. Okay, so let us draw that configuration. Now slider will be closest when this OA crank will be completely like this OA. Okay, this will be OA, and then this, it will be like this. The slider will be here. This angle they have called the crank angle that time as phi. This distance is the offset and we know it's 65, and this is the S minimum, right? So from geometry you can see that this angle is equal to phi. So this angle is also equal to phi at this configuration, right? So what we can write here is sine of 180 minus phi, which is this angle, okay, it will be equal to perpendicular this distance upon this 65, right? Wait a minute, this is perpendicular is 65, sorry. So it will be 65 upon this distance, right? So how do we calculate this distance? This will be the whole AB minus the portion which has gone beyond this, that will be 20. So it will be 107 point, what did we get it as, 107.769. So 107.769 minus 20, because we know that this length, okay, it was already equal to OA, so that was 20. Now this OA has gone back side and this has completely extended. So the total length was 107. Now 20 has gone beyond this point. So this will remain as 107.769 minus 20, right? So what is this coming out to be? So 180 minus 5 will come out to be, when you solve this, it is
It's 0.74.
0.74. I think you are making some mistake. It is coming out to be 47 degree here. Okay, you have to take the inverse on both sides, right? 180 minus 5 ko to
Okay,
sine
ma'am.
inverse of this. So it is coming out to be 47. So 5 will come out to be as 133 degree. You can cross check it once. Are others getting this answer?
Ma'am, it will be 227
Yeah,
degree high.
theta will be, not phi. Theta is as 2 phi, na?
Okay, ma'am.
Yeah, so phi is coming out to be this
Ma'am,
again.
ma'am, actually it's sine 180 minus phi is equal to 65 upon AB length. I have to take the length of AB.
No, not AB. See, you're thinking that this AB, uh, see, if you imagine, you have two links like this, right?
Yes,
When
ma'am.
it's completely extended. Now, this connection does not have to break. So, when this length will go beyond this, what do you think? This length will not stay, na? This will go with this. So,
Mm.
some part will be cancelled with this. So
Okay,
that
okay, I
length,
got it, ma'am. Okay,
this will
okay,
remain, right? So that 20 gets minus from 107, okay? So you have to
okay.
visualize these things. So basically this is the length OA. Then AB goes from this length. So this length gets subtracted and this length will remain, okay? So phi is 133 degree, right? Everyone is getting this? Now what next? When you calculated phi, now in question we have been told that what will be the crank length when theta is equal to theta is equal to
2
2
5.
phi. So basically theta is given as 2 into 133 degree, which is equal to 266 degree, right? Now this is the final configuration for which you have to figure out. So what you have to figure out, that this theta is given as 226 degree. In that configuration, this will look something like, say this theta has gone beyond like this, okay? So this will be A, this will be O, this will be the slider, and somehow like this, okay? So this has gone beyond this, let me draw it again. If this is your fixed link, okay, this is your fixed link and OA angle has been gone to 266 degrees, so it will be something like this. So this will be your O, this will be your A, okay? Then something like this, okay? So in that case, you can again draw the slider crank mechanism. Then you can write the coordinates as we did in question number 1, right? You can write the coordinates, then equate the lengths and get the output which you have to actually find out s. Or you can simply, if you memorize the formula, so the formula we know, okay, we know from inverse kinematics that the crank length for a 3R 1P mechanism is equal to S is equal to L2 cos theta 2, basically theta output, sorry, not theta output, the theta input, so theta 4 is the theta output, so L2 cos theta 2 plus minus under root of L3 square minus L2 sin theta 2 minus E squared. Okay, so this is the formula. So this is the formula which we directly get when we follow those procedures. Okay, as we did simply in question number 1 also, when we follow this procedure, we arrive at this link length, right? Like, sorry, we arrive at this equation. So you must have done it in the videos also. I will not repeat the whole procedure. It is similar to question how we did it in question number 1. So now here you can put the values, right? So what is L2 here? L2 will be OA, equal to OA. So that is
20
20.
mm.
20.
Yeah, so it will be cos of 266 degree, because theta has been given as 25, which is 266 degree. We just calculated. Then plus minus under root of L3. So L3 will be AB. So it will be 107.7 square minus 20 sine of 266 degree, minus what is E, 65 whole square. So you will get two values of S from here. So tell me what it is. S12. Calculate this equation and tell me what you are getting. Anybody calculated it? Quickly, what you're getting? Okay, I have solved it somewhere. Yeah,
Mm, minus 60, 6885.2.
I guess you're making some mistake. It shouldn't be that. What I am getting is minus 99.82 mm and 95.14 mm. Anybody else getting these answers?
Ma'am, it's coming near 86.
86. No, I have cross checked it. Let me see. Now it is coming out to be this only, so you can maybe check it once more. Okay, after the class you can check the calculation, but this is what I was getting when I was calculating it. So here you are getting one negative value and one positive value, so obviously here the distance of the slider cannot be in negative. Okay, it's not going beyond the fixed point, otherwise it will be an inversion. So we know that it is staying in this direction only. So 95 will be the correct answer. You will discard the negative value. Okay, clear? So now we can move to next question. So this I want you to try, because now we have done two questions, so I will give you some time and you will have to solve it. Okay, here what it is similar to question number 1, but here it has been given that for the slider crank mechanism, calculate the value of crank angle theta when the slider has reached a distance s. So this s is given to you, it is given as 70 mm. Okay, this e is given to you, oa is given to you, okay, it is 15, and this AB is given as 100. Now you have to figure out the crank angle theta. Okay, so you have to basically, here this is a problem of inverse kinematics. So S has been given and you have to figure out the theta, right? So how do we do it? You can again follow the same procedure, that you can write the coordinates of this point, then you can write the coordinates of this point. Okay, you can fix your maybe origin here, or you can fix your origin here, whatever suits you. Okay, so if you can fix your origin anywhere, so then you can write the coordinates of point A, then you can write the coordinates of point B, then you can subtract them to get this equate with this distance. Okay, so this is how you can do it. So that is one way. Another way is simply that if you remember the formula, you can do it in that way. So whatever way you wish, you please do this question and tell me what you are getting the value of theta. Okay, because we don't have much time, and I think only 50 more minutes are remaining, but we have to do 10 questions, so we are on this third question only. Okay, but if you understand the concept, then you can do the remaining questions yourself also, but at least try it yourself. Okay, are you guys trying it?
Yes, ma'am.
Okay, then it's fine.
Ma'am, 179 degree.
179, I guess it's not correct. You might be making some mistake. Anybody else? Okay,
Okay. It's
you
coming,
can.
but it's
Yeah,
really small. 1.05.
1.05. I think. How are you doing
Hmm.
it? Can you explain?
No, with the formula.
Okay, what is the formula?
Um, Mom, here it's given A is equals to E, the offset.
Hmm.
B we are taking as S,
Hmm.
and C as L2 square plus S square plus E square minus L3 square by 2 L2.
Yeah, that is correct. Then theta 1 is.
Then theta is 2 tan inverse of A plus minus root over A square plus B square minus C square by B plus C.
Yeah, you're using correct formula, but then why you're getting wrong answer?
Ma'am, we have to take E as negative.
Yeah, if you are fixing your coordinate here at O, the E is downside the y-axis, no? So it's minus 65 and S is plus 70.
I did that way only, but it's coming wrong.
Okay, you might be making calculation mistake. So please take care of these things, because if you're doing the correct procedure, then you're definitely making a calculation error, right? So here I am doing the same procedure. I'll not follow the lengthy one. We can just use the formula. So theta is equal to 2 tan inverse a minus under root of a square plus b square minus c square upon b plus c. Okay, and here a is equal to e, b is equal to s, okay, and c is equal to L2 square plus s square plus e square minus L3 square upon 2L2. Okay, now for this chain, okay, which has been given in the question, this OA will be the L2, right? Because this is the fixed link, then OA will be L2, so it is 15 mm. Then L3 will be this AB, it is equal to 100 mm. S is given as 70 and E is given as minus 65. Okay, so you can put these values here. So theta will be, okay, this is plus and plus minus. So theta will be 2 tan inverse of this is minus 65, okay, plus minus under root of 65 square plus b is what, s, and that is 70 square. So what is this distance coming out to be? Minus c. Anybody calculated what is c? Anyone calculated the value of c like this individually? Okay, let
My value of C was coming minus 21.6.
minus 21.6. Let me check once. Okay, so L2 is what, 15 square, right? L2 is 15,
Yes, ma'am.
so it will be 15 square plus s is what, 70, 70 square plus 65 square minus what is L3, 100, right? 100 square divided by uh, what is L2 again, 15. Yeah, that is correct. So this will be minus of c square. So c you can again take as 21.6 squared, right? And in the denominator we have 70 plus c, so it will be 70 minus 21.6. So yeah, this is the equation you are getting, and when you solve it, there will be two angles corresponding to plus and minus sign here. So theta 1 is coming out to be minus 146 degree and theta 2 is coming out to be 60.23 degree. Okay, So these are the correct answer. Just have to solve this equation. You're making some mistake, right? Is it clear?
Ma'am, why you take a minus 65?
Yeah, see, when we were solving this procedure, right, we fixed our coordinate system here, then we took the origin here, then I was writing the uh, coordinates of this point with respect to this, and I was writing the coordinates of this point. Now when you write the coordinates here, this is in still in positive x direction, so s will be positive, but this is in negative y direction, so you will take minus 65. Okay, it's with respect to origin you're deciding the points. That is from where this formula came, right? Ultimately this formula was the whole derivation when you took the coordinates of this point and the coordinates of this point. So in those coordinates you will have to take it as minus 65. Okay, you cannot take it as plus 65, right?
Yes, ma'am.
Okay, so uh, this question was also like, if you remember the formula for inverse and forward kinematics of 3R1P chain and 4R chain, then these things will be very simple for you. Otherwise if
Mom,
you
it's
want to
still
integrate
coming like
also.
so small.
Sorry,
Mom, answer is still coming that small. Minus 2.5 or 1.05.
I think you're making some mistake. Let me
Mom,
uh,
equation is
I'll
coming same.
wait. Yeah, yeah. Say.
Mom, my equation is coming same as yours.
So are you doing it in calculator? You might be making mistake because if your equation is correct,
Um,
can you
yes,
mute
ma'am.
yourself because yeah, mute yourself because when I speak, I think echo is coming when you are also keeping this on. So this is the same equation, but answer is coming out to be that only. You might be making some mistake on calculator. Okay. So your equation is correct. So the answer should be minus 146 and 60 only. Okay. I'll see it at the end of the session once again, and you can also verify once, and then maybe in tomorrow's class, if your doubt is still not resolved, we can discuss. Okay, but try once.
Ma'am, is it 143 degrees somewhere?
Yeah, minus 146.
Ma'am, actually my calculator was set in radians.
Yeah, that is why your answer is coming out to be wrong, because it's has to be in degrees, right? Because you're taking all the angles in degree. So so can we move to the next question if that is clear?
Yes, ma'am.
Yes, ma'am.
Okay. So let's do this one. So the question is, for the mechanism shown below, find S when theta is 50 degree. L1 is given as 100, L2 is given as 60 mm, and E is given as 30 mm. So it is simply a inverse kinematics problem. No, forward kinematics problem simply. You have to find S and when theta is 50 degree. So quickly do this because it will not take much time. Even if you do it by geometry, even if you do it by the formula, it will not take time. So give this answer. If you want to use the formula, you can use the formula, but otherwise we can directly do it. See, I will do it in this manner.
Ma'am, it is an inverse kinematic problem.
No, it is basically forward because theta is given and you have to find S, so it will be forward kinematics only, right?
No, ma'am, it's input actuators we have to find. A given output is there, theta is given, and we have to find input. Actuator displacement is input, so it's inverse.
Yeah, in case of, I guess, yeah, in 4R we have theta 2 as input and theta 4 we get as output. But in,
Actuators displacements are input, and we have to find here input.
okay, okay, anyways, you know that you have to find out S, right? So,
Yes, ma'am.
so okay, you can figure that out. So basically, forward and inverse kinematics depends mostly on the problem you're dealing with. Sometimes you don't have to remember if it's actuator displacement or anything. You just have to remember if the input is given and you have to figure out the output at the, yeah, if the actuator input is given and you have to find out the output, then it is a forward kinematics problem. Yeah, Nikhil.
Ma'am, my value was S was 70.615.
Yeah, that is correct. So, yeah, what we do is that in forward kinematics problem, uh, if suppose you have been given a robotic manipulator, in that case there will be some joint angles which you will want to your robot to move, okay, and the end effector position will be your output. So if your end effector position is given and you have to figure out the theta, what joint angle will be there for that position, it means it is an inverse kinematics problem. But if your joint angles are given that this is your given theta, find out the end effector position. In that case, displacement becomes your output and your theta becomes your input. So that will be a forward kinematics problem. Okay, so it will really depend on the question that what is your input and what is your output. So that really doesn't matter because ultimately the procedure is going to be the same. So yeah, if you have gotten the answer, did you do it directly by the help of formula? Those who have gotten the answer, Nikhil, how
Yes,
did you do
ma'am.
it?
Ma'am, by the help of formula.
Okay, you can do it that way, but see, if sometimes you do not remember the formula and still you see such questions, try to figure out if there is it is possible by geometry or not. Now see, if you look at uh, this triangle AB, let me call this as C and let me call this as O. Okay, so if you see in triangle ABC, we know that this is perpendicular, right? So AB will be what? Under root of S square plus E square, right? This is something you know. And here also theta is given, L2 is given and L1 is given. Do you know any formula which can relate them? You know, right? You know the cosine rule. Cosine rule says that L1 square plus L2 square minus AB square is equal to what? 2 L1 L2 cos of theta, right? So here you can write L1, sorry, you can write L1 square plus L2 square minus 2 L1 L2 cos theta is equal to AB square. Now AB square is equal to what? S square plus E square. Okay, from this equation you can put is equal to S square plus E square. Now S is given to you, right? No, S you have to figure out. Okay, so you can simply write it as L1, uh, you can write this equation as S square is equal to L1 square plus L2 square minus 2 L1 L2 cos theta and minus E square. Okay, so here it depends. If S were given, you would make the equation in form of theta, then it would have been a that problem. So okay, the procedure won't change whether it is a forward kinematics or inverse kinematics. So from this equation, you know that E is given, L1, L2 is given, theta is given. So you can find out S. Here also you will get two values of S. The negative value you can discard and the positive value. Okay, you will get plus minus 70.615. Okay, I was getting S as plus minus 70.615. So you will keep this 61, the 70.615, which is approximately equal to 70.62. Okay. So sometimes you don't remember the formula, just do it by geometry. Even you have like the previous question which we did, this was also possible by geometry if you could connect these points. So I'm just saying, in case if you ever forget the formula or anything, you can uh, do this method also. Okay. So now we have question number 5. So for the mechanism shown below, we have to figure out S. Link length L1 is given, L2 is given, L3 is given, L4 is given, and L5 is also given. So basically you have to figure out S. Okay, theta is also given, you have to find out S. So how do we approach this question? Anyone?
Ma'am, here both 4R and 3R1P
Yes.
mechanism will work.
Yeah. So that will be your approach, that this is a 4R chain, this is a 3R1P chain. You will solve the 4R chain first to figure out this theta. Okay, theta output, let me call it as theta output, theta naught. So you will solve this chain because L1, L2, L3 and L4 all are given, this angle theta is given, so you can solve this and get the value of theta naught. After getting theta naught, this is a 3R1P chain where you have to figure out the S and theta is given, right? So can you quickly do it? Calculate the value of sorry, calculate theta naught. Okay, and tell me what are the values you're getting. Nobody got the answer. So here we can simply use the formula. Okay, theta naught is equal to, again, 2 tan inverse a minus under root of a square plus b square minus c square upon b plus c. Okay, this is plus minus. So a is sine 70 degree, right? B is cos of 70 degree minus L1 by L2. So L1 here is given as, L1 is 700 upon L2 is given as 300 mm, and C is given as L1 square plus L2 square plus L4 square. So L4 is 600, 600 square minus L3 square, and L3 is 450 upon twice L2 into L4, right? These are the values which you put in this equation and you will get two values of theta, right? So what are the values you're getting? Anyone did it? So when you plug in these values here, you'll get two values for theta, which is, one is minus 246.74 degree and another is 196.21 degree. Now can anyone tell me which of the following two which we consider? Because ultimately we have to figure out the S. So if we want to figure out S, we have to use the value of theta 4 in 3R 1P chain, right? So which value should we consider here?
196.
196. Why so?
So in that case, 3R 1P, we can use that formula for the given length and the cosine.
Yeah, but why not minus 246?
We can put also, but we have to take in negative in that case. Both are the same value.
No, both are not same
For
value. They are,
that triangle, that will be the outer angle,
uh,
and we have to reduce from that 180.
no. Anyone else? Anyone else can say which angle will be considered? See, we have been given this configuration here, and this 70 degrees fixed, right? Matlab, this angle is given 70. Okay, it is fixed. So when this angle is fixed, and since this is a Grashof chain, it cannot cross this fixed axis. You understand that, right? In a Grashof chain, the mechanism or the configuration that is given cannot cross the line of the fixed plane, right? So this chain cannot go beyond this. Okay, it cannot form a mirror image against this line. It cannot cross this fixed line. So it has to remain above this line always. So if you see, our answer comes out to be either minus 246.74 or 196.721. Now 196.21 is clearly greater than 180. It means if you are measuring the angle from here, it will be something like this. It will cross the line. So this angle is not possible. Now we have 1 minus 246. So minus 246 means that you are measuring the angle from this side. Okay, so we can measure the angle from this side. If we measure the angle from this side and it comes out to be minus 246. Okay, let me subtract it from 360. 360 minus 246.74. So this is coming out to be 113. It means it is somewhat here. So this angle is 113 degree. This angle will be sorry, not this angle. This angle will be 113 degree. This angle is 246 degree. So this can be possible. Okay, because in this case the link is not crossing this fixed plane. Okay, so that is why we select this angle and we discard this angle. Okay, understood? Any confusion in this?
No, ma'am, no.
Understood, na? Okay.
Yes, ma'am.
So you will consider this angle. Okay, now you have to put this angle in the uh, uh, in finding the S for the 3R1P chain. This also you can simply do by the help of a formula which you know, or otherwise you can simply use the cosine rule. Okay, so see, you know, this is your L4. Now this theta naught you have calculated. This is what? L5, right? And E in this case is 0. Yeah, so this is S, right? Now you have to figure out S, and I just now we talked about cosine rule. So what does cosine rule say? That S square plus L4 square minus L5 square is equal to 2S L4 cos of theta naught. So here S is given, S you have to figure out. So this will be a quadratic equation in S. So L4 is given, L5 is given, and it will be a quadratic equation, and you can find out the value of S. Otherwise you can simply use the formula which you were using for 3R1P chain, and you can calculate this and tell me what the values you are getting.
Ma'am, 150.
I guess 150 is incorrect. It should be 271.65 mm. That is what I was calculating. I was getting two answers, minus 745.45 and another was 271. Okay, wait a second. Is it asking the, no, is it asking, it is asking the S value only. So the S value is coming out to be 271. Anybody else got the same answer?
Can you please once tell the value of L5?
L5.
L5.
Wait a minute. L5 is 750.
Okay.
750.
Yeah, 750 mm. So basically when you plug in the values, let me do it for you here. You will get an equation as S square plus 473.885 S is equal to 202500. So you can solve this quadratic equation, okay? And here you will get two roots. One is 271 point something and another will be minus 745. So we will take the positive one, okay? If this is clear, then maybe we can go to the next question. Otherwise, if you have any doubt, you can ask.
Next problem.
Okay. Yeah. So, is it visible? Let me zoom it. So, the question is that the slider crank mechanism shown below moves from initial configuration with OA vertical, okay, to the final configuration C on y axis, okay. So, it is a slider crank mechanism. This is the initial configuration, this is the final configuration, right? So, what has been asked is that calculate the distance traveled by slider during this process. Okay, so initially this was like this A C O B, and finally this A moved to the downside, basically uh, this link here. Okay, it shifted like this, and this C point came here, and this is the final configuration we achieved at. Now, initially we would have some S. Okay, so we can call that S initial, and finally we got some S final. So what we have been asked is calculate the distance traveled. So we have been asked to find S final minus S initial. Okay, so what is the net distances it traveled? So S delta has been asked in the question. OA has been given as 400, AB has been given as 600, and AC has been given as 300. Okay, AC, AB, and OA have been given. So here you can clearly see S initial can be figured out very easily. It can be done by the Pythagoras theorem. Okay, it's 600, it's 400. So you can calculate S initial. Then here you have to calculate S final. So first tell me the value of S initial, what you are getting for S initial. And you can give this some time, so I'll be just right back. Okay, you can try this question. I'll give you 2 to 3 minutes and I'll be back in that duration. Thank you for waiting. So, did anyone solve it?
Ma'am, delta S is coming out to be 273.89.
273. I think you mean 372, 327.
No, ma'am, 273.
No, it's 327. Or maybe let me check. I might have written it wrong. 774.9 minus 7.21. So, no, it's 327. So, uh, sorry, I lost my network for a moment. So, what is the value of S initial you're getting?
Ma'am, 447.213.
Yeah, that is correct. So, S initial is coming out to be 447.21. Okay, now moving to the next part, the second configuration. Okay, you will just keep it here. The second configuration which was given is this is C, this is A, this is O, and this is B, right? So this is S final, and we don't know it. Okay, so there are two ways of solving it. Okay, I'll show you the easy one so that you'll be able to solve it properly. Now tell me, what is this AC length equal to? Quickly.
AC 300.
300, right? What is AB equal to?
600.
600, right? This OA is equal to
400.
400, right? Now let me draw a perpendicular from this point A to here. Is it fine? Now you know that in any triangle, okay, in any triangle, the if we draw a line segment from here to here, the ratio of this line segment to this line segment will be equal to the ratio of this line segment to this line segment. Do you all know it?
Yes, ma'am.
Yes, ma'am.
So here also 600 by 300, let me call this as uh, basically, say, let me call this as x and let me call this as y. So 600 by 300 will be y by x. So it implies y will be what? 2x. So it means if this whole length is 3x, this will be x and this will be 2x. Correct? But we know that this whole length is equal to s final. So x plus 2x is equal to s final. So it implies x is equal to s final by 3. So here again we know that this length is, let me write it simply as s. So it will be s and it will be s by, sorry, it will be s by 3 because it is x, and it will be 2s by 3. Any doubt till here? Any doubt till here?
No, ma'am.
Now you can apply, you know that this is a perpendicular. You can apply Pythagoras theorem for this and find perpendicular, and same for this, and it should be equal. Obviously the length is same, so it should be equal. Okay, so let me shift this here. Okay, Yeah, let me shift this here. Then we can write here perpendicular square is equal to what? 400 square, sorry, 400 square minus s by 3 whole square, right? It should be equal to what? From this it should be equal to 600 square minus 2s by 3 square. Now you can simply solve this equation. Solve this and tell me the value of s quickly. You just have to take 400 to the right side, and we just calculated 600 square minus 400 square. That is coming out to be this 447 point something. And you can take this here to s square 2s by 3 whole square on the right side. Okay, let me do it anyways. So what you can do is you can write 2s by 3 whole square minus s by 3 whole square, right? uh, yeah, 2s by 3 whole square minus s by 3 whole square is equal to 600 square minus 400 square. So this is coming out to be s square, okay, by 9.
It's coming out plus minus 77.45.
Yeah, that is in meters. So it will be equal to, wait a second, uh, yeah, so s square by 3, so it will be 600 square minus 400 square. Hmm. It will be 2 into 10 to the power 5, right? It will be 3 into 3, so it will be s is equal to under root of 6 into 10 to the power 5. So yeah, so this is coming out to be plus minus 774.59, right? Is it coming out to be the same?
Yes, ma'am.
Yeah. So now we were asked about delta s, okay. So our initial s is 447.21, and we know that we have to obviously calculate the positive x because it is moving in that direction. So it will be 774.59 minus 447.21. 447.21. What is this coming out to be?
327.38.
327.38. Okay, so this is the correct answer. Okay, so okay, it's not given, the answer is not given in the options, so this is the final answer. Okay, any doubt in this question? Understood till here?
Yes, ma'am.
Okay, so now we have further 1, 2, 3 and 4 questions, but we don't have much time, so what I can do is, okay, they are pretty simple only. Let's do one by one. So what is the statement 1? Can somebody read it? Read the question number 8. Paridhi, you can maybe.
Yes, ma'am.
Hmm.
Statement 1. Arkman's steering mechanism has simple and robust construction because of the use of R pairs. And statement 2 is perfect steering condition can always be achieved through Arkman steering mechanism.
So two statements have been given, and we have been asked which one is correct and which one is incorrect. So uh, statement 1 is correct or not?
It is correct.
Statement 1 is correct because we know that
Yes, ma'am.
the construction of Arkman's steering mechanism is relatively simple then. uh, because it has only R pairs. Okay, it has 4 R pairs, so it is simple. Now, perfect steering condition can always be achieved through Arkman steering mechanism. Okay, so in a perfect steering condition, what is the what is the condition for perfect steering? Can anyone tell me what is the perfect steering condition?
There will be a no friction.
Sorry. Yeah, no slip condition is the perfect steering condition, but if we write it down mathematically, so cot of uh, phi L minus cot of phi R, okay, is equal to B by L. This is the condition for perfect steering. And how, sorry, what is happening to this? Yeah. So if our steering mechanism is something like this is our front tires, okay, and this is our rear tires. So we say that perfect steering condition exists when both of these tires or all of these tires rotate about a single instantaneous center of rotation. I don't know what is happening to my iPad. It's stuck. Wait a minute. Okay. So this happens sometimes. So okay, let me draw it here. So we know that if this is our vehicle and this is our steering mechanism, so all of these wheels will continuously rotate about a particular instantaneous center of rotation, and when it happens then there is no slip condition and we say that this is a perfect steering condition. So these axes pass through the centers of the wheels, and this angle here it is phi L, right, and this angle here is phi R. So the condition is that cot of phi L minus cot of phi R should be B by L. Now B is this length, okay, and L is this length, okay. B is the length between the two wheels, and L is the length between the front and the rear wheels, okay. So this is L and this is B. So these two are fixed. Now this condition should be satisfied every time to have a perfect steering mechanism. But in Arkman's steering mechanism, what we see is that that is a 4R chain and it does not always obey this rule, okay. This rule is not always obeyed by the Arkman steering mechanism. So perfect steering condition cannot be always achieved in Arkman steering mechanism. In some certain conditions, if we are able to do it, then that is possible, but mostly it is not. So statement 2 is incorrect, okay. So statement 1 is correct and statement 2 is incorrect, okay. Is this clear? Any doubt in this one? Now we can move to the
No,
next question, okay. Yeah, Nikhil, you're saying something.
no, ma'am, no doubt.
Okay. So the question is the locus of point B shown in the figure below where point A is pushed towards left will be. Okay, when point A is pushed towards left. So basically this is asking the locus of this point. So locus basically means what? Nothing but the trajectory or the how the x and y coordinates of this point are changing or what relation they have, that is the locus of this point. So how do we get that? Can anyone tell me? Anyone? How do we get? See, what we do is we basically write the x and y coordinate of this point. Okay, the x coordinate. We first establish a coordinate system. That is the first step in solving every problem. You have to fix your coordinate system from where you will measure the distances, or from where you will define like measure a vector. So that has to be fixed. So you can fix that anywhere. You can fix that here, you can fix that here, you can fix that here. Okay, I'll not prefer here because this is also moving, so I'll prefer my origin to be either here or either here, whatever it is fixed. Then I can define the x coordinate of b and the y coordinate of b with respect to that point, and then I can see if there is any relation between x and y. That will give me the locus of any point. Okay, that is the basic basic procedure that should come to your mind whenever you are asked a locus of a point, that I should first define its x and y coordinates, or if it is in 3D, then the z coordinate also. So tell me what will be the let us first say where our origin is. Let me define this as origin. Okay, it's not necessary you take it here, you can take it here also, that is up to you. You can take your origin here, but I have taken it here. So this will be my y axis and this will be my x axis. So can someone tell me what will be the x coordinate of b? Quickly, it's not that difficult. What is the x coordinate of b? This length is L by 2, this is L by 2, matlab all of these are L by 2, right? So what is the x coordinate of b? Okay, so this is the x coordinate of b. So it will be, this is L by 2 plus L by 2, so this whole length is L. So the x coordinate will be L cos theta. Okay, what will be the y coordinate? This is L, so it will be L sine theta, and this will also be L sine theta. Why? Because this is L and this one will be L sine theta, so both combined will be 2L sine theta. Now can we figure out a relationship between them? Yes. Why? Because we can write it as xb by L is equal to cos theta and yb by 2L is equal to sine theta. Now we know that cos square theta plus sine square theta is equal to 1. So we will square both sides and add. So it will be xb upon L whole square plus yb upon 2L squared is equal to cos square theta plus sine square theta, that will be equal to 1. So this is the locus. So the question is the locus of point B. So basically this is the equation. So you know that this is the equation of an ellipse, right? With L and 2L being the major and the minor and major axes of the ellipse. Is it clear? So this is how you solve any problem where you have to figure out the locus of any point. Okay. Find the relationship basically between the coordinates. Okay. Is it clear? Then we can move to the next question.
Yes, ma'am.
Okay. So, okay, these two questions are simple. So please do it quickly because it's just formula based question. So what is the value of L for perfect steering condition? Theta L has been given, theta R has been given, and B is given. Just now I told you that the perfect steering condition is cot of theta L minus, is it minus or plus? Minus, I guess, yeah, minus cot of phi L minus cot of phi R is equal to B by L. Now phi L has been given as 35 degree, phi R has been given as what? 45 degree, and B is given as, sorry, B is given as 1 mm. So what is the value of L? Find out.
Ma'am, it's 2.336.
Uh, yeah. So L is coming out to be 2.33 meter. Okay, it's meter. It's not mm. Obviously, steering length cannot be in mm. So you have to take care of these things also. So this is the correct answer. Okay. So now the last question for today. For Davis steering mechanism shown for a right turn, find the value of phi r. So we have been given the lengths B, A and H. Okay. And even the phi L has been given. So what is the Davis steering mechanism? Like what is the condition for a right turn of Davis steering mechanism? Can anyone tell me? It is nothing but, you have to remember it, cot of phi L. There is a whole derivation which you have gone through the lectures, okay, but I'll not do that here. You will remember these formulas. It will be cot of phi L minus cot of phi R is equal to what? For perfect steering, it was B by L.
2
For Davis
V by
steering, it is B minus A by
H.
H, right? So B has been given, A has been given, H has been given, phi L has been given. So you have to find phi R. So quickly do this and tell me what you are getting. Let me also do it here. So cot of 25 degree minus cot of phi R is equal to 1.2 minus 0.7 upon 0.5. So cot of phi R will be equal to cot 25 minus 1, which is equal to 2.144 minus 1. So cot of phi R is equal to 1.44, which implies tan phi r, 1 by tan phi r is equal to, okay, let me write it like this. Tan phi r is equal to 1 upon 1.44, which is equal to 0.873, something like that, and phi r is equal to tan inverse of 0.873, which is equal to 41.14 degree. Is everybody getting the same answer? Let me
Yes,
check
ma'am.
it once. Mm, yeah, 41.4 degree is the correct answer. So I hope these two questions were very simple. So rest are also like the questions are not that difficult. There is a standard procedure of doing those questions. You just have to keep that in mind. Okay. Then there will not be a like lot of variety in the questions. If you know the basic concept for how to solve for 3R 1P and 4R chain, that is the maximum you will be getting, or a combination of 3R 1P, that also you have done. Okay. So I think that is it for today. So uh, tomorrow there will be another session, right? From 3 to 5. It will be on week 4. So uh, then we can like discuss. Have you gone through the week 4's lecture or content?
No, ma'am, not yet.
Okay, yeah, that is the problem. Like some of the students, they are not able to complete the this weekly lectures on time. So, anyways, you can just still join the class tomorrow, or you can, if you're not able to watch the lectures, if you're able to watch the lectures till tomorrow, then it's fine. Otherwise, you can basically when you would complete that, you can watch the YouTube video for the same. Okay. So, is there any doubt which you have to ask regarding today's session? Otherwise, I'll end the session if there is no doubt or anything.
No, ma'am.
Okay. So, should I end the session for everyone?
Okay, ma'am.
Yes, ma'am.
Okay, okay. Okay, thank you.